Hello kids! Our journey with heat and temperature continues. Let's dive into how heat flows into different materials around us. Understanding this helps us figure out how they heat up or cool down. And it's super useful in everyday life. It helps us choose materials for building better houses, picking the right clothes for different weather, and even choose the best kitchen items. For example, some materials are great at conducting heat. These are called conductors, like metals. That's why the part of the pan that touches the stove is made of metal. It heats up quickly to cook your food. But what about the handles? They are made of insulators, materials that don't conduct heat like plastic and rubber. This helps your hands safe from getting burned. Let's explore this game to experiment with conductors and insulators. Which material is the best thermal insulator? Metal foil, polystyrene, or cardboard? Let's think about it. Metals are excellent heat conductors, so it's not the metal foil. What about cardboard? Cardboard is an insulator, but it's not the best one. The best insulator here is polystyrene, because it doesn't let heat flow through it easily. Now, for the next part of the experiment, we will test how fast heat flows through these three materials: polystyrene, cardboard, and metal foil. But first, what happens without using any material at all? As you can see, without any insulation, the temperature drops quickly and reaches the room temperature in just 10 minutes. Now, let's go to the table and fill it out. So after 10 minutes, it was 18. Let's start with our first material, polystyrene. Since polystyrene is a great insulator, you can expect it to take more time for the temperature to decrease. Let's check. Your guess was correct. After 10 minutes, we will stop. It's still kinda warm, so it's 45. Let's continue. Every 10 minutes, we will pause and record the temperature. 37 at 20 minutes. 31 degrees Celsius at 30 minutes. At 40 minutes, it's only 25. Still didn't reach the room temperature. At 50 minutes, it's 21. And finally, when the time is 60 minutes or 1 hour, it will be reaching the room temperature. Heat flows slowly through thermal insulators. When we used polystyrene, it took almost 60 minutes to reach the room temperature. What about the cardboard and the metal foil? For the cardboard, it will still need some time, but shorter than the polystyrene. After 10 minutes, it's 28. And finally, the metal foil. Because the metal foil is a conductor, it will take shorter time for the temperature to reach the room temperature. Let's check. After only 10 minutes, it's 20 degrees Celsius. And at all the next times, it will be 18 degrees Celsius. Good job! We have finished the table, so when we don't use any material or when we use conductors, heat flows quickly. But in insulators, heat flows really slow, and the best insulator as we seen in the table is polystyrene. That's all for conductors and insulators. Look around you and classify everything you see into conductors and insulators. Stay tuned for more science videos with Science Nuggets. See you soon!